Sleeves. Quality work is a product of highly trained professionals who strive to do a job right the first time. In this program, you will be presented with work procedures required to install compression sleeves on electrical conductor. By following these procedures, you will help to ensure public safety and the safety of linemen who will work on the same lines in the future. Studies have shown that one of the leading causes of line failure and power outages is the incorrect installation of electrical fittings. For this reason, the objectives of this course are to provide you with the information required to identify the correct compression sleeve for a particular size of conductor, to identify the correct size of dies for the different sizes of sleeves, the procedure used to prepare the conductor to ensure a low-resistance electrical splice, and the appropriate techniques used to install compression sleeves according to the manufacturer's recommendations. Terms and definitions. Compression splice. A compression splice is used to join two conductors while maintaining a low-resistance connection between them. The mechanical strength of a properly installed sleeve is as strong or stronger than the breaking strength of the conductor itself. Conductor. The conductor is used to transport electricity from its source to the end user. Usually, low-resistance metals such as aluminum or copper are used. Resistance. Resistance is the opposition to the flow of electrical current. Resistance in a connection or joint results in power loss and should be minimized. Conductivity. Conductivity is the ability of a conductor or electrical fitting to conduct electricity. Where less resistance is present, conductivity is higher. Oxidation or corrosion. Oxidation of aluminum is the direct result of contact with air. Oxidation increases resistance, and if not removed before installing a compression splice, it will increase the resistance of the joint. Tools and equipment. The tools used in this video are a manual compression tool and its removable dies, a wire brush and gloves. The hand-operated compression tool is used to install connectors, sleeves, and other fittings throughout the distribution system. The compression tool used in this program has two fixed dies, which are located in the head of the tool. The dies are used to install different sizes and types of electrical fittings. The dies are labeled O and D3. The D3 die is also used as a seat for removable dies. Further information on the care, use, and maintenance of compression tools is detailed in other programs in this series. A wire brush should always be used to thoroughly clean any oxidation or contamination that may be present on the conductor prior to installing any electrical fitting. Sleeve and die identification. To ensure a low-resistance, long-lasting splice, the correct sleeve must be used. Each sleeve is stamped with the size of conductor for which it can be used. This and other data is stamped on the exterior of all quality sleeves. Make sure that the sleeve indicates the size of conductor to be spliced. Die size is also indicated on the exterior of the sleeve. This is indicated in this example by the statement Use Die Index. This sleeve requires a die of 243-BG or 687. It is important to select the correct size die required by a sleeve. Each sleeve requires specific dies to provide the proper compression during installation. Caution: do not attempt to determine sleeve size visually. Always read the data indicated on it. Tolerances are precise, and incorrect sleeve or die selection will result in premature failure of the fitting. Note: some manufacturers indicate that dies from other manufacturers should not be used on their sleeves. Do not mix brand name dies and sleeves without specific authorization from the sleeve manufacturer. Inside of each sleeve is an antioxidation paste. This serves to inhibit the oxidation process after the installation of the sleeve. Sleeves without this paste should not be used. Conductor preparation. Use a wire brush to clean the conductor thoroughly to remove all oxidation and other contaminants. This will ensure a low resistance connection. Never use a knife to clean the conductor. This damages the conductor and does not adequately clean it. Always use a wire brush. Splice installation. Once the appropriate splice and dies have been identified, the compression tool is checked for calibration and removable dies installed if required. Prepare the conductor by wire brushing it. Then place the conductors to be joined into the sleeve by forcefully inserting the conductor until it is stopped by the center wall within the sleeve. It is important that the conductor is fully inserted into the sleeve before you begin compressing. Place the compression tool approximately 1 centimeter from the center of the sleeve and make the first compression. Repeat the crimping process from the center of the sleeve to the outer edge until you obtain the required number of compressions. Then, repeat the process on the other side of the sleeve. Normally, the number of compressions that are required are indicated on the sleeve. Notice the lines on this sleeve. These indicate where a compression should be made. If you are using a sleeve that does not have lines on it, overlapping crimps should be made every 1 or 2 centimeters. When you are not using W-type dies, rotate the tool 180 degrees between each compression in order to keep from bending the sleeve. If the sleeve bends during installation, do not use a hammer to straighten it. As always, quality control is important. Remember to inspect all completed work to make sure it has been done correctly. If removable dies were used, remove them from the compression tool and store properly. Make sure your compression tool is adequately cleaned and stow it in its metal case. Other types of splices as compared to compression sleeves. To demonstrate the quality and strength of a well-installed sleeve, we will show mechanical test with other types of connections. Some of these improper splices are known as Western Union splice, the compression connector, sleeve from one manufacturer installed with dies from another. None of these examples are as strong as a well-installed sleeve. When the Western Union splice is tested using a dynamometer, it began stretching immediately. At approximately 700 pounds, the splice pulls apart. Note that it fails at a rated load less than the rated conductor strength. Using the dynamometer test on a connector shows that it loosens and pulls apart at a force of approximately 400 pounds. Again, note that it fails at a rated load less than the rated conductor strength. When the dynamometer test is applied to a sleeve that has been incorrectly installed with another manufacturer's dies, the splice breaks at approximately 1,400 pounds. Notice that the cable breaks within the splice at a rated load less than the rated conductor strength. When a properly installed sleeve is tested using the dynamometer, the cable breaks at 2,100 pounds. Further inspection reveals that the conductor broke away from the sleeve, proving that a correctly installed sleeve is stronger than the conductor. Review. To ensure you make a quality sleeve installation, follow these steps. Identify the correct sleeve for the conductor. Identify the correct dies that should be used with the sleeve. Make sure the compression tool is properly calibrated. Install removable dies if required. Clean the conductor with a wire brush. Insert the conductor into the sleeve until it comes to rest against the center dividing wall. Place the compression tool approximately 1 centimeter to the side of the center of the sleeve and start compressing. Repeat the previous step, working your way towards the outer edge of the sleeve until the required compressions have been made. Repeat the process on the other side of the sleeve. Inspect your work to make sure it has been done properly. If removable dies were used, remove them from the compression tool and store properly. Make sure your compression tool is adequately cleaned and stow it in its metal case. Remember, one of the most common causes of outages are connections which fail due to improper installation. The methods presented in this program will result in quality, low resistance, long life splices. This in turn reduces the hazard to the general public and provides safer working conditions to those who will work on the same line in the future.